All right, we are going to do simplifying radicals. This is going to be lesson 1. So again, we want to take some sort of square root, in this case, some sort of square root, and simplify it. If it's a perfect square, square root of 16, this would be 4, right? Because 4 times 4 is 16. That's the easiest part. But the problem is we're going to do ones that aren't perfect squares, like the square root of 20. What is this simplified? So when you simplify radicals, I'm going to scroll down here. We already talked about that. Here, the radicand, remember the number or the term inside the radical, that's called the radicand. It's in simplest form. Simplest form if it contains no perfect squares. No perfect squares. So we're going to factor. We're going to factor to determine if it's in simplest form or not. So let's do this one. So by factor, what two numbers multiply together to get 48? And if it ends in an even number, use 2. So in this case, 2 times what equals 48? 24. And then you do it again. We don't have to do it with 2 because the only thing that'll multiply to 2 is 2, right? 2 times 1. So we want to factor till we get to prime numbers. Prime numbers. Numbers that you can only multiply with themselves in times 1, right? Prime numbers. So 2 is prime. So what multiplies into 24? 2 and 12. Again, 2 is prime, but 12 isn't. So 12 would be 2 and 6, right? 2 times 24 is 48. 2 times 12 is 24. 2 times 6 is 12. And then 6, 2 times 3. And 3 is prime. So we're finished, right? This is called a factor tree. And I needed to see this factor tree for all of these problems we do. So now we want to look for pairs, right? So pairs, right? 2 of each number. So we have a pair of 2s and another, right? We have 2 groups of 2. So what this means is whenever you find a pair, you can bring one to the outside. So in this case, we have this 2 goes to the outside, this 2 goes to the outside, and we have 3 left over inside. So that stays inside. And then 2 times 2 is 4 root 3. All right, there's 1 here, 1 here, and then the 3, because it doesn't have a pair, it stays inside. This is when we're doing square roots. Things are going to be different for cube roots. But square roots, we're looking for pairs. We're going to do another one, so don't worry if it's a little too confusing right now. We'll do some more, and it'll be a little clearer. Let's see what this next one is. So 100. So this one is a perfect square. We know that this is 10, but this is what we're doing is if we factor it, let's say you forgot that 100 is a perfect square, we'll factor it. 2 times 10. 2 times 10 is not right. 2 times 50. We can do 2 times 25, and we can do 5 times 5, right? 5 is prime. We can't factor these numbers anymore. So we're going to circle our groups of 2. So we have a group of 2 2s, and we have a group of 2 5s, and there's nothing left over. Since there's nothing left over, that means it's a perfect square. So on the outside, we have 1 2 and 1 5, right? For every pair, you bring 1 to the outside of the symbol. In this case, we have a pair of 2, so 1 would come out, and we have a pair of 5, so one of those would come out. And then 2 times 5 is 10, so 10's our answer because we have nothing left over. That's if it's a perfect square. Let's do another one. So 48. So we're going to factor it. And I'm going to start with 2 because it ends in an even number. I could start with any number, but I just think it's easier to do 2 and 24. And now 2 and 12. And now 2 and 6. And now 2 and 3. So we're going to circle our pairs. That's a pair, right? When you have 2 of the same number, you group them. So this is a pair. And this 2 is a pair. So for every group of pairs, you bring 1 to the outside, right? 1 out here. So I have this 2, and then I have this 2. And then inside, I have this 3 because it's all by itself. So it stays by itself. And then so 2 times 2 is 4 on the outside and 3 on the inside. Let's do another one. 18, simpler one. So again, I'm going to do 2 times 9. Choose prime. So that's done factoring. And then I have 9. What goes into 9 is 3. 3 times 3. Now, if I circle my pairs, I have a pair of 3s. And only one lonely 2. So for the pair of 3s, I bring 1 to the outside. And on the inside, I have this 2. So this would be my answer. Hopefully that makes sense. The part that confuses people is they end up not noticing that this is the end of the tree. So let me, I'm going to do 18 again right here so you can see what I mean. Sometimes when you're making this tree and it gets really long, it's hard to see. So sometimes when people are done, they'll like box it or mark it so they know that these are the final parts of the tree. It just gets hard to see if it's really long. But then circle your pairs, bring 1 to the outside, and what doesn't have a partner, what's by itself, stays in the radical. Another one, 12. So we have 2 and 6. And then we have 2 and 3. So if I circle my pairs, 2 and 2, and then I have a lone 3. So the 2's on the outside and the 3 is on the inside. And this is my answer. I'm going to do some more of these. I printed out a bunch. I'm going to do them over and over again until I get bored. So I don't know how many that's going to be. But again, we're doing our factor tree. I'm always going to do 2. I could do 10, I could do 5, but I'm going to do 2 and 10. And then 2 and 5. So my pairs, my groups of 2 is here. So that means I have one of these I put on the outside, and on the inside I have 5 left over, and that's my answer. So I can't do 2, but it does end in 5. So I'm going to do 5. 5 times 9 is 45. And then I have 3. So a group of 3s, so 1's on the outside. One of those 3s is on the outside, and the 5 is all by itself. It's on the inside. Why this works is because this, we could say 45 is the square root of 5 times 9. And 9 is a perfect square, which is 3. So that would go on the outside. And 5 would go on the inside. Don't worry about this. The reason why I don't teach it this way is because doing this is easier. If your math skills aren't great, this is easier, and this might confuse you. So if you understand this, you can do it this way. But if you don't, just keep doing it the way, just do it by making a big factor tree. So 18, I feel like I did 18, but let's do it again. 2 times 9. Again, 9 is a perfect square, so I could stop, but I'm not going to. I'm going to do it completely. 3 and 3. So I have a group of 3s. And then so 1 3 on the outside and a 2 on the inside. 48. I feel like I did 48, but let's do it again. This one's longer anyway, and you can see how you might get confused. I do 48. I divide it by 2 first to get 24. Then I divide 24 by 2 and get 12. And then I divide 12 by 2 and get 6. And then I divide 6 by 2 and get 3. And now I got to circle my pairs, my groups of 2, right? My groups of 2 numbers. So that's a group and that's a group. So for every group of 2, I bring one of those to the outside. So I have this 2, and then I have this 2, and then inside I have a 3. And these 2 numbers that I bring to the outside, I have to multiply them. So that's going to be 4 root 3. So 8 is going to be 2 times 4. Again, square root of 4 is 2. And then I'm going to factor 4, 2 times 2. I'm going to circle my pairs. So I have 1, 2 on the outside and 1, 2 on the inside. I did this one too. If you know the square root is 100, you can just write 10, but we'll do this. This time I'm going to do, no, I'll keep it the same. 2 and 50, 2 and 25, 5 and 5. Circle my pairs. I have 2 2s and 2 5s. So bring 1 2 on the outside, bring 1 5 on the outside, nothing left over. So my answer is 2 times 5, which is 10. A few more of these. 125. Again, this ends in 5. So I'm going to use 5, but you can really use whatever you want to divide it. Just don't get confused if you do something bigger. I'm going to use 5. So 5 and 15. No, 5 and 5, 25. That was bad. And then 5 again. 5 and 5. And then I circle my pairs. I have 1 5 on the outside, 1 5 on the inside. So 2 and 40, 2 and 20, right? I'm just 80. The 2 numbers that multiply to equal 80 are 2 and 40. And then 2 and 20 is 40. 2 and 10 is 20. 2 and 5 is 10. And then I circle my pairs. So I have 1, 2. So that means I have this 2 and then this 2. And then 5 on the inside. So that would be 10 root 5. Not 10. 2 times 2 is 4. 4 root 5. Right? You multiply, right? I bring 1 out and I bring this one out and I multiply them together to get 4. I'm going too fast myself. All right, 5, 75. What 2 numbers multiply to get 75? I could do 5. 15. What 2 numbers? This 5 is prime, so I'm done with 5. And then I have 15 is 5 times 3. And now these are prime. So I'm going to circle these. So I have 1 5 on the outside and a 3 on the inside. 27. 27 is harder if you don't know your multiplication tables. But it's 3 and 9. And then 9 is 3 and 3. So I have a pair of 3s, so that means one goes on the outside and this one stays on the inside. So 50, I'll do 2. 2 and 25, 5 and 5. Circle my groups of 2. I have 2 5s. One goes on the outside. One of these 5s goes on the outside. And this 2, since it's all by itself, it stays underneath the radical. It stays here too. So 32, 2 and 16, 2 and 8, right? I'm just dividing by 2. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. And then I'm going to circle my pairs. Circle my groups of 2. So that's a group of 2. And that's a group of 2. So one on the outside, another one on the outside, and then 1, 2 stays in the middle, stays inside the radical. 2 times 2 is 4. So that's my answer, simplify. 16, I feel like I did 16 already. 2 and 8, 2 and 4, 2 and 2, groups of 2, groups of 2. So I have one of these 2 on the outside, another one on the outside, and nothing inside. So 2 times 2 is 4. That's my answer, 4. 2 and 18, 2 and 9, 3 and 3. Circle my groups of 2. I have 2 2s and I have 2 3s with nothing else. So it's going to be a perfect square. I have a 2 on the outside and a 3 on the outside, right? I just bring one of them out. 2 times 3 is 6. 6 is my answer. All right, 2 more. 12. 2 times 6 is 12. 2 times 3 is 6. And these are prime. So I can't go anymore. So I'm going to circle my groups of 2. So I have a group of 2 2s. So I'm going to bring 1 to the outside. And then my 3's left over right here. Inside. And that's my answer. So for this one, again, I'm going to start with 2. 2 and 32. 2 and 16. 2 and 8. 2 and 4. And 2 and 2. I'm going to circle my groups of 2. So there's one group of 2, there's another group of 2, and there's another group of 2 with nothing left over. So this must be a perfect square. So I have 2, right, this one, and then I have another one, and then I have another one. Right, one of these 2's on the outside, one of these 2's on the outside, and one of these 2's on the outside. 2 times 2 times 2 is 8. So square root of 64 is 8, which is true. So I know I did it right. All right. We'll do some more practice with this together. And we'll see how we're doing then.